This is the easiest third question ever on GCSE mathematics. Our first step is to convert any mixed number into a top-heavy improper fraction. To do this, we keep the denominator the same, in this case 16. We always multiply to the side, and we add number on the top. Here, 16 times 2 gives us 32, and 32 add 13 gives us 45. And that's still underneath the square root. And here we're subtracting 2 over root 5. When squaring a fraction, we can square at the top and square at the bottom separately. Simplifying root 45, and the largest square number, that's a factor of 45, is 9. Hence, I'm going to rewrite root 45 as being root 9 multiplied by root 5. On the bottom, I know the square of 16 is 4 as a square number. And I've still got negative 2 over root 5. I know the square of 9 is 3, so it comes directly outside the root. So I've got 3 lots of root 5 over 4. And I'm still subtracting, as I want my answer as a single fraction, and there's no root on the bottom, therefore leaving the first fraction alone. Looking at my second fraction, I currently have root 5 on the bottom. Therefore, to rationalise, I need to multiply the top and bottom of my fraction by root 5. As long as I times the top and bottom by the same thing, I'm keeping the fraction equivalent. Therefore, on the top, I have negative 2 lots of root 5. And on the bottom, I should know that a root multiplied by itself just gives you the number or letter. So root 5 times root 5 is simply 5. As I want my answer as a single fraction, looking at numbers in the bottom of my fraction, I want to find the lowest common multiple of 4 and 5. The first number that appears in the 4 and 5 times table, in this case, is 20. So I'm going to change each fraction to be out of 20. Looking at the first fraction on the bottom, what have I times 4 to get to 20? I've times it by 5. Hence, you must do the same to the top to keep it equivalent. We're multiplying involving thirds. If it's outside, we times the number outside. So 3 times 5 is outside. So there's going to be 15 lots of root 5. Look at my second fraction. What have I times 5 on the bottom to get to 20? Well, I've times it by 4. Hence, you must do the same to the top to keep it equivalent. And negative 2 times 4 will give us negative 8 lots of root 5. Now, as each fraction is out of 20, I can write this as a single fraction over 20. Looking at the tops here, I've got 15 root 5 subtract 8 lots of root 5, as they both end in root 5. Hence, they're like terms. So I just add or subtract the numbers in front. So 15 lots subtract 8 lots will give us 7 lots of root 5.